So today we'll discuss about the how GPIO interrupt work, what basic settings needs to execute any interrupt through the EXTI line. So we have seen that there is 24 EXTI line. Uh, so first of all, we see that the block diagram of EXTI block diagram. So whatever interrupt comes through the EXTI line, that interrupts basically goes through the EXTI to NVIC controller, and NVIC controller decided which interrupts should execute right now depend on the priority and sub priority, and CPU execute this corresponding ISR. So this actually the this peripheral connected to the APB bus, and there is multiple register, pending register, interrupt mask register, software interrupt, and event register, rising and falling edge, whichever edge detection you want, you have to set that. And there is also the event mask register, which will trigger the interrupt. So one by one we will see the interrupt, and we'll practically create a code and then execute that. So whatever the pin you want to use as a whichever GPIO pin you are going to use as a external interrupt. So in basically my development board there is the PC13 switch is connected. So PC13 will use as a external interrupt. So every EXTI line is connected through the multiplexer, while the PA0 pin is connected in a EXTI 0 line, and in this way EXTI while the GPIO PA1 pin, PB2 and PB, while the port pin number 1 is connected EXTI1. In this way, if I have taken the PC13, so EXTI13 will be my EXTI line. Okay, so in this way there are 15 EXTI line, and another some peripheral also connected to the EXTI lines. There is PVD, RTC alarm, and USB. In this way 24 EXTI line is available in this controller. Okay, so there is multiple register. The first one is interrupt mask register. So the default value of this register is 00. So wherever EXTI line you want to use, this corresponding bit should enable, otherwise the interrupt will not triggered. So in my case there will be the this pin should set to enable the interrupt through the EXTI line 13. Then this one is for interrupt mask register to enable the interrupt line. The EXTI line I want to use, so I have to enable this. I have to set this. I have to write 1 in this 13 position. And next is event mask register. So I want to consider as a interrupt, not as a event. So I will not configure this. Okay, if you trigger an event, then you have to set, or you have to control this register. Okay, next is which trigger you want to select, rising edge or falling edge. So I basically want to rising edge, so I have to also set this corresponding bit for setting the event on rising edge of this switch. If you want to trigger falling edge, then you have to select this. If you can also select both rising and falling. Uh, if you want to consider both the event, if rising happened then also event triggered, and for if falling also occur then event also triggered, then you have to consider the both. Then the next is the software interrupt event register. Is basically if you want to consider that you simulate a execute the ISR without the hardware interrupt, then you need to set this, otherwise skip. I basically take the hardware, not the software interrupt. So if you want to get software interrupt, then you have to trigger this, but I don't want software interrupt. I get the hardware interrupt. For hardware, external interrupt will come and corresponding ISR will execute. But if you want to uh, execute the ISR without the hardware, only the hardware interrupt, you only uh, you can generate also the interrupt through software. So in that case you have to set this. Okay, so that corresponding EXTI line will set the pending bit and interrupt will occur. Now the pending register, whichever EXTI line event or uh, interrupt occur, that interrupt is occurred, that corresponding pending register will set. Pending register bit will set, and you have to clear. Here is the interesting thing, should take care that if you want to clear the bit, still you have to write 1 to this location, then it will this bits is set when the selected edge event arrive on the external interrupt line. So that corresponding line, when a event occur, then this bit will set, and this bit is clear by programming to it 1. So you have to write 1 on this location, then its flag will clear. Okay, so let's go to the project. I have corrected my board, and I have generated a project. You can go in this and select that PC13. I have selected PC13, this pin as a EXTI line, and you have to also go to the system GPIO, and then you have to select the NVIC. I have enabled the NVIC pin. You can also tick this to generate the interrupt, enable the NVIC pin. Okay, then generate the code, and there is only, I have nothing in this. Whenever button is pressed, the this corresponding IRQ will execute, because the EXTI 10 to 15 same IRQ actually given for EXTI line 10 to 15. So PC13 fall in this number, so that IRQ will execute whenever the PC13 EXTI line 13 interrupt occur. Okay, so I have write some a single line to indicate that in our board there is 3 LED. There's 3 LED will glow whenever the interrupt come into this handler. So I also use a breakpoint to see that it is coming or not. So just go to debug mode by clicking that, and just okay, debug mode is start, and I go to SFR and just select the EXTI register. So we will see the pending register that in our case this PC 13 bits PR 13 bit should be 1 whenever I press the button, and there it will come to that line where I have enabled the EXTI line. Inside the GPI enable, there is the set the NVIC priority, and also enable the IRQ in this line. This IRQ I have enabled. Okay, so just run, and right now I am pressing my switch. Once I press the switch, it's a halt here. Okay, as I have used the breakpoint, and it is halted here. And you also see that the pending register 13 bit is becoming 1. So to clear this bit, if you not clear, then what happened? It continuously executing the ISR. Once it come out the ISR, again it will see that there is a pending bit, then again it will go to execute the ISR. So you can see also here I have resume, then still it is again come into this. So once you enter the ISR and execute the ISR, then you must clear this bit by writing 1. So just come out and write the corresponding. So PC 13 clear the pending register. Once it's clear, it will not execute again. So you can see right now here. So how I get this? So come and just start. Now right now I am pressing the switch, then it's again come here. Then after executing, it's clear the pending register bits. Okay, if I press again, you can see uh, let's see once more. Now it's becoming 1. Once I resume, it's become 0. Okay, why it is not updating? Because it is now it will updating. Once I pause, it will update. Okay, so how I get actually the IRQ number, and which IRQ I can So this basically actually mentioned in the mm, this reference manual, and also there is a startup file which actually mention all the thing. If you go to the startup file, there you can see that all the dummy implementation of this uh, corresponding ISR EXTI line, which you have to understand first which line is connected to the which corresponding EXTI line, and that EXTI corresponding EXTI dummy implementation also mentioned here, and you can go and uh, as it is weak, mentioned as a weak attribute, so you can overwrite this ISR, line as it is mentioned as a weak attributes. So just copy that, and whenever you want to write this function, just write as a simple function like this, and inside that you can clear the pending bits. Or if you want that it will as per your logic, whichever it is you record only one time execute the ISR. In general, it is only whenever the interrupt occur, then it will serve the ISR and clear the pending bits. So in this way, basically the interrupt working. Thank you. If you have any doubt, you can comment.